Thanks for joining me today, Sahi. Let's talk about machine learning and audio processing. So, start by sharing with us a few concepts people need to be aware of, how they're used, and who's responsible for continuing these innovations that we all depend on.
Okay, so let's start with what it exactly means to do machine learning in audio processing. And there are like a lot of different things that you can do. Let's start with the most obvious ones that everyone talks or does, which is noise suppression. I want to remove clapping sounds from the actual audio, sorry, which we're not going to do in this recording, I think, because there is no.
Obviously, because I heard you.
Yep, exactly. But there are systems that do that. For example, Google Meet, I think Zoom as well. And you can decide to, enable it, disable it, put it into a certain level of sensitivity. And what noises do you cancel babies or not? Do you cancel dogs that are barking? Do you cancel your neighbor that usually decides to renovate his house whenever I do calls? So there is that. And it started somewhere in the beginning of the pandemic, and we still have it today with companies adding that in different ways. Then there are things like packet loss concealment. We've seen WaveNet from Google that does that for Google Duo, where they say, well, it looks across the packets that were received, and then we're going to estimate based on that what the packets that were lost should have been. But that's by listening to the audio itself, which is machine learning in nature. So I can do packet loss concealment with machine learning. I can also do things like forward error correction. How much to invest in forward error correction based on what happened in the past in the packet loss side. Okay, I can do it without that. I can do it with that. And today, when you see companies starting to think about and investing in when to use forward error correction, they're not trying to do it with rules, but they're trying to just throw machine learning at that, because that's what we do today when we develop. We stop thinking, we've got machine learning to do it for us. Good or bad, that's a different question. I think the two other areas that you see today is codec compression. Lyra is a machine learning based codec. At one point, it will come to WebRTC. Opus version 1.5 has a lot more machine learning than previous releases of Opus, which still had machine learning in them. And then you can also say, well, we can do echo cancellation with a bit more machine learning than we're doing now. And again, there are companies that do that. The other two things that you start seeing today, one of them is to change the voice. I want to sound like someone else. That's an option. Okay. And the other one would be almost the opposite. I want to have my voice signature and then use that. And I can play with that. I can decide, let's remove Tsahi's accent because we want him to speak English and not Hebrewish or whatever it is that I'm speaking with my own accent today. And I might want to do that and use text instead, or we might use that to improve the audio on the receiving side, for example. It's not packet loss concealment, it's not forward error correction. It's me sending text and you receiving my audio as it should be, or sending something akin to text. So you see all of these things that are taking place today in media processing, and I guess I'm the only one speaking, but I guess the answer it is that whatever you can do with an algorithm today in the media processing pipeline of audio, we're starting to see companies trying to replace to machine learning. Why? Because we can.
Yeah. Well, you didn't hear me speaking for a moment there because I was doing traditional noise suppression. I went on mute while there was a noise in my building here. So that's the old
Okay.
manual way of noise suppression. Um, and obviously, in the old manual way of echo cancellation, I'm using as well with my headphones.
Mhm.
You obviously have more faith in the echo cancellation built in, but these techniques are interesting too because there's different. I guess I would say, not really being a machine learning expert myself, but kind of
Mhm.
different levels of the sophistication needed in them, right? I
Yeah.
mean, echo cancellation to a degree is looking for a repeating pattern and cutting off the repetitions of that, right? Packet loss concealment, a little more sophisticated because you're doing some synthetic generation of what those missing packets should look like. based
Mhm.
on the surrounding ones, right? And then, of course, changing the voice is interesting. We can use the web audio API to process it before using that stream, right? But that's going to add in latency and complexity.
Always.
And then, you mentioned accents. I had a synthetic voice sample generated off of my voice once, and it was fascinating because when it spoke in English, it was pretty good. I could probably tell the difference. I'm not sure others could, but
Mhm.
then they had it speak in Spanish, which was really impressive to me because while I do speak Spanish, I speak Spanish with a bit of a North American US accent, right? So
Mhm.
hearing what a synthetic voice, how it would speak Spanish with a better accent, but still in my voice was really I don't know if it was inspiring or humbling. I've got a little ways to
Yes.
go still,
Were you
right? But there's
frustrated because of that?
no, I do okay. I do okay. No, it was just kind of helping me know what the next level should be, at least according to
Okay.
the AI for me, right? But
Mhm.
I think it was still cool because, if like a great application of things like that, right, is if I wanted to do a Spanish language version of WebRTC Live, for example, right?
Mhm.
I could try to do that, but it's not going to be anywhere near as good as doing that with AI, right? So us being able to do that in recordings, and you've talked about seeing that at conferences in real time done as well, I believe. Pretty cool stuff.
Yep.
But obviously, different layers of the sophistication necessary to do that. Give us a quick idea of where, because these things can build on each other, right? There's some
Yep.
built-in echo cancellation in
I'll start
WebRTC, but others
before
can
you
use
go
it as
to
well.
where.
Yeah.
I want to talk about the echo counselor. You said that it's easy, but now let's complicate things.
Okay.
We do echo counselor. It's easy, but then there's this stupid thing that I was told that is called reverb. And reverb is when everything is glassed around you,
Hmm.
and whatever audio is there vibrates from the walls or whatever in the room and gets into the microphone.
Right.
Okay, with or without video conferencing, with or without having something speak out at the same time. What if I want to remove reverb? So a few
Hmm.
years back, when I recorded my own courses, I had the audio, I sent it to someone on Upwork. He said, we can't remove the reverb. It's impossible.
Hmm.
It's too much work. It's manual work. So I had to go and buy this nice microphone and go and record in studios instead because this has less reverb. I have no clue why, but it's condenser and
Right.
whatever. I'm clueless about that. Um, but today, if you want to remove reverb, there are algorithms, machine learning based, that can do that. So even if you think about things like, well, echo counselor is easy, once you take that on itself to the next level, you can start saying, well, now we can do better things if we're more intelligent in how we do that.
Right.
Okay. Um,
Yeah. That easy should always be put in
yeah.
quotes. There's some video AI that we need. Whenever I say easy, finger quotes should
Yes.
appear on the screen automatically.
Yep.
So there are multiple layers of this between hardware, software, browsers, operating systems. I mean,
Yep.
that's a lot of different parties kind of responsible for this.
Yes. And the answer is no one is responsible besides you. Okay. And you can be either the application developer or it can be the end user. What do I mean? I can bring a better microphone.
Hmm.
In the same way, I can install an application that would improve the audio and do noise suppression or whatever it is that I want across all the applications that I have. We have such a thing called Crisp AI. You can go download, pay them, and you have that running across everything. I can edit as an SDK to an application, again from Crisp AI or a third party using open source into my application, and then it runs only in my application. I own that as a service provider, and I offer that as part of the solution. It might just be that it happens to be something that is available in my laptop or PC or phone to begin with. For example, echo cancellation with or without machine learning. Okay, that comes from the CPU or GPU or whatever. Someone magically decided that this should be there. You see it a lot more today in video, where all of the GPU, CPU, and GPU vendors are trying to talk about super resolution for YouTube and gaming. There would come a point where they would say the same for video conferencing because they can. And then scaling up something with machine learning, which is called super resolution, will happen to be something that is available in the CPU, and it's not something that I need to add as a developer. Other things end up inside the browser for us automatically. Opus has a bit of machine learning in it. We all enjoy that. We don't know that it's there, but it is. It selects which codec to use internally because Opus is actually two separate codecs. And it does that based on if it is hearing noise or speech. Noise for it is music, okay? In this case. So you have different places where you can do that, and I can also do it in the server. For example, NVIDIA Maxine is a server platform with software that does some of the things that I just discussed earlier on the server side. And now I need to send the data to the server in order to do that. I do it there, so there are privacy issues on one end. On the other end, I have it everywhere for whatever scenario that I want, regardless of the device that is using it. Do I have enough CPU there? Is it on the hardware of the chip of Intel or whatever? I couldn't care less. It just works for me. Okay, noise suppression for Google Meet, for example, at least in the past, I don't know now, they said that that happens on the server. They process that in the server and not in the client. So where exactly these things go, I don't know. It depends.
Yeah. Yeah. And there's trade-offs between them. In the cloud adds latency, on the client adds processing power.
Yep.
You know, there's a lot to consider here. So as you said to me just before we started recording, there's no easy answers on this. And so we'll have to leave it there for today. But definitely important topics for any WebRTC application developer to look more into and not be fully dependent on what's provided to us. As you said, it is up to us as developers as well as the individual users of the applications. So thanks for sharing your insights with us as always, Tsahi. To learn more about Tsahi's work, you can check him out at bloggeek.me. And to learn more about future episodes of WebRTC Live and our work, check us out at webrtc.ventures. Thanks a lot, Tsahi.
Thank you, Arin.